Hello students, and welcome to part 5 of our video series. This week we're going to be covering Ohm's law. So this is to give you an overview of where we're at. We're going to be starting to move towards this idea of circuits, right? So all the physics that we've been studying recently is building towards how we're going to apply it in the rest of our lab. So we talked about charges, right? So electrons and protons and the forces between the charges. So we have a good understanding that a positive charge will be attracted to a negative charge. We talked about the influence of those charges on their environment. This is basically the driving force of our circuits. And then we talked about capacitors, which is something that we could use inside a circuit as a component. And then we talked about how electrons move through materials in last week's lab, where we talked about resistance and resistivity. So again, we're taking the theory that we learned, and now we're kind of moving into more applied physics. So that in mind, since the main driving point for the next few labs is going to be circuits, it's very important to get in the mindset that we are going to be now pretty much primarily focusing on circuits. So Ohm's law is one of those critical laws that is very, very, very useful in circuits, and it's something that you could use to do many calculations, because it's very useful to know like the voltage and the current and stuff like that at a specific area of your circuit, and that could help you engineer devices and control devices. With that being said, after we go over Ohm's law, we're going to move into simple circuits, right? So we're going to learn about different types of circuits, and then we're going to learn Kirchhoff's rules, which is another way we can evaluate circuits to power devices. So Ohm's law, we kind of introduced the idea in last week, so you saw the equation. So now we're going to more formally introduce the ideas of Ohm's law. So there's not going to be really much I can add. We're going to learn the difference between an ohmic versus non-ohmic material. So let me begin by just starting off with what Ohm's law is. So Ohm's law is given right here by this equation, right? So Ohm's law is basically your current is equal to your voltage divided by your resistance, or you may commonly see it written as V equals IR, where your voltage is equal to your current times your resistance, right? You could solve this equation in many different ways or rewrite it, but it's the same equation. So just like last week, I gave you a simple series circuit or diagram just to learn these concepts. We're going to do the same thing, right? So you basically have some power supply, which could be a battery or an outlet. Then you have your current going through your circuit, which is given in amperage, and it's basically your rate. And then you have your resistance, right? What's slowing down the current. And so these are the three physical quantities that we're going to be looking at: voltage, current, and resistance, where voltage is measured in volts, current is measured in amps, and resistance is measured in ohms. This is important to know your units, right? And like we talked about last week, your resistance is measured in ohms, and it's basically is equal to your voltage divided by your amperage. You get it directly from Ohm's law equation. I wrote an A here. You could put V is equal to V over I is equal to your resistance. So that's worth knowing. That being said, this is all the physical quantities that we're going to need to know. The next thing that we need to know is the difference between an ohmic versus a non-ohmic materials. So in this lab, we'll be doing some plots, and those plots are going to tell us if we have an ohmic versus non-ohmic material. So how do you know if it's an ohmic material? Well, it's going to follow Ohm's laws, right? So a material is ohmic if it has a constant resistance for a wide range of voltages, and that means it's going to follow Ohm's law. So if it doesn't have a if it doesn't have a constant resistance for a wide range of voltages, then it's going to be a non-ohmic material. I'll try to make this a little bit clearer in a second, right? So a non-ohmic material, it'll vary, right? It's going to vary on changing the current, the voltage, and the temperature, and other variables. So if the resistance isn't constant, then you have a non-ohmic material. If the resistance is constant, then you have an ohmic material. That's the main takeaway. And we're going to do some graphs, right? So when you do a voltage versus current graph, it should be linear if you have an ohmic material. If it's nonlinear, then that means you have a non-ohmic material. So here's how to tell mathematically if you have an ohmic versus non-ohmic material. So just like I said, when you plot your voltage versus your current, right? So in your lab, you're going to be able to change the voltage, and then you're going to measure the current. So when you change your voltage or increase your voltage from 0 volts all the way up to whatever they tell you, if you have a ohmic material, you're going to get this nice little linear graph. And then last week we did a lot of this. You should know that the slope of this graph will tell us something, right? So if you look at Ohm's law equation, right, where V is going to be your y-axis and I is going to be your x-axis, right? So you're going to be dividing voltage divided by currents. Well, that's going to be equal to your resistance, right? So this, looking at this graph, we had a lot of practice last week of this. You should know that your slope of these curves is going to give you your resistance. So that's a good thing to point out. Now, again, your non-ohmic material, your graphs will not be linear, right? You can tell, like in this graph, it's not linear at this point. It's changing directions. This graph is going up. There's many examples of non-ohmic materials, but the key takeaway is if you don't have a straight line like this, it's going to be non-ohmic, right? So if you have a straight line, if you have a perfect linear line, or very close to perfect linear line, because we don't live in a perfect world, then that means it behaves as an ohmic material. But if you have a non-ohmic material, then you're going to get some funky looking curves, so that means your material is non-ohmic. So that's the kind of key takeaway of this week's lab. Again, we kind of got introduced to these ideas last week. Now we're just going to reinforce it. And the next week, we're going to be taking Ohm's law equation. So it's very important that we go back and basically commit this to memory, where your current is equal to your voltage divided by your resistance. So write this equation down, because this is going to be a very fundamental equation that you're going to be using for your circuits. That's going to be very useful, especially in next week's lab. So next week's lab and lab after that, circuits are typically going to be the most challenging labs. So trying to have a good understanding of what we're doing and why is very important. So just know that the idea is that we're moving towards circuits and we're learning how a circuit works, right? So we're going to have some power supply, some current, and some resistance. Next week I'll make a little bit longer video on how to solve circuits correctly, and we should be having some fun. So if you guys have any questions, just let me know. Send me an email, as always. Thank you for listening, and I'll just put my email up right here. And again, you know my office hours are going to be held on Wednesdays from 12 to 3 p.m. I know last week I had a few work events to do, so I couldn't make my normal office hours, so I put them on Thursdays. But this week, my office hours are going back to Wednesdays. So thank you and have a wonderful week.